Hi everyone, thanks for joining. Just give me a second and I'll officially start the webinar. I'll just toggle on our live streaming services. So if you can't watch us on Zoom, you can watch us anywhere else, wherever it's convenient. LinkedIn, YouTube, we're all live streaming there. So yeah, thanks everyone for joining. And today's webinar is called Gemini 1.5 Pro Native Audio. I think it's related to Gemini Flash, right? We'll also cover that. So Alex
Yes.
actually came up with more content on Gemini Flash, so that's going to be fun. And uh, this webinar covers native audio, file API, JSON mode, and a 1 million context window. So, and obviously Gemini Flash as well. So, stay tuned, stick till the end if you want to try out hands-on. I'll be providing the resources for this webinar in the chat. So, if you guys have attended before, we actually utilize the Q&A button for the questions, right? But this time we are actually using Discord so that we can actually have a discussion in real time during the webinar. So our Discord channel has a dedicated server for the webinar Q&A. So I'll be putting in the link for that in the chat. And just know that you are currently in a listen only mode and we will not be taking up any questions through raising hands or like uh, anything else or even the chat. I think it's disabled for the participants. So you can utilize the Discord channel and we are all active there. Alex is there. I'm there. So if there's anything, please let us know. I'll be providing the resources to everything that's relevant in the chat. So keep an eye out for that. And allow me to announce today's speaker. Alex is here with us. He's a regular speaker at our webinars and he's a growth engineer here at SingleStore and has done a lot of webinars with us in the past. So this will be a fun topic. And yeah, please, Alex, take it away. And thank you everyone for joining.
Sure. Thanks, Yukti, for the intro. Thanks, everyone, for joining today. Exciting topic lined up. Gemini 1.5 Pro will be covering how to use the native audio support, uploading files with File API, JSON mode, doing some RAG over audio descriptions of files, and using a single store database, and then also just kind of briefly doing an overview of what the Gemini models do in the LLM landscape today. Great. So just to level set for everyone, I've been doing these webinars for a while now, but just so everyone kind of has the same kind of base level of knowledge, let's talk a bit about this emerging architecture that we're seeing for LLM applications. And so if you've been building with LLM apps at all in the last 2 years, then you've definitely heard of this term called RAG. And for those that are unfamiliar, Retrieval-Augmented Generation is the way by which we provide context to a model outside of its training data set so that it's aware of facts and information, private internal information, external facts and figures, so that when it's giving us a response, it's not doing this thing called hallucinating. It's not lying to you. And so at a really high level, really what this looks like is your end users will come up with a prompt, which then gets passed to your Gen AI app. That prompt, has some pre-processing and post-processing that happens to it, and we'll talk about this in a second. That then leads to a vector that embeds over your company data. And then finally, you enrich the LLM's context window with the relevant data, and the LLM is able to provide an accurate response. And so just zooming out even a little higher than that, this AI stack architecture that we're seeing, where at the very uppermost layer, you have the UI, then you have the API endpoints, and finally your contextual data layer. This is really the kind of gold standard that we're seeing emerge for LLM applications. And why is that? Well, obviously, on every application, if you have any sort of user-facing function, you're going to have some kind of UI, right? But as the UI connects into the API endpoints, with the kind of emerging LLM ecosystem that's come around, generative AI, you find that you kind of need to connect to a lot of different services. Maybe your users need to be able to chat about images. They need to be able to upload audio files. Maybe they're, connecting to their Google Calendar, to their Gmail, to their Jira. They also want to be able to chat about tickets that they're, assigned to. All of that data comes in through the API endpoints, and then finally it flows into your contextual data store. And so here at SingleStore, we think that SingleStore is the best contextual data store. Obviously, there are other options that you have available to you, but the reason why, and we'll get into this in a second, but at a high level, the reason why is SingleStore handles all sorts of data, including structured and unstructured data, all at real-time latencies of sub 100 milliseconds, allowing you to read and write from your data as fast as you can throw at it. And so just zooming into this contextual data layer. Oh, it looks like we had someone join Yukti. Oh, weird.
I have no idea.
Just yeah, just zooming into this contextual data layer. What does the contextual data layer actually look like under the hood? Well, really what this means is SingleStore is taking as an input all forms of the data that you're concerned with, the streaming data, your structured data, JSON, and unstructured data, including images, audio, video. That's all bundled together with your compute, allows you to govern the data all in one single plane. And then as an output, obviously you get your data products, your data stories. And we'll talk a bit about what vectorization means. So vectorization, we just going back to this slide here, we just talked a bit about what retrieval-augmented generation looks like at a high level. Really how that works under the hood is when your user gives a prompt to your app, what you're doing is you are passing this prompt through something called an embedding model, which then creates a vector, and that's this process of vectorization, which then creates a vector that you can later query to find similar vectors to this user's query vector in order to grab context that's relevant to the LLM's response, and so that the LLM's response is grounded in facts that are relevant to the user's query and not just sort of plucked out of thin air, as you'll often find, if you ask an LLM, what color was, this website element on this date, right? It might give, just some, if you ask that question without any sort of context at all, it might give you, an answer that a user would just take at face value. But if you actually enrich it with context, like for example, the code from the website, and maybe you have periodic backups of the website, then it'll actually give you, a relevant answer. And the way that you find that context is through this process called vectorization. And then also there's other techniques that you use, just, exact text search, lexical search, that SingleStore also supports. But what should we think about when we are vectorizing, right? Vectorization allows us to perform what's called semantic search over our corpus of data. And you can think of semantic search compared to something like a Google search, right? Where you're searching for something exact. You can think of semantic search as like a fuzzy search that allows you to match concepts against other concepts and find, if you searched for the word, animal, for example, and you had, a corpus of vectorized images, then you might get pictures of, dogs and cats and cows and pigs, that sort of thing, right? Or if you searched for, and we'll go through the code today, if you search, for example, classical music and you had vectorized a corpus of, all of Spotify's, music library, then you would get back, classical music as opposed to, indie music or electronic music. So vectorization is really going to be key for data types that you would like to perform fuzzy searches over. So text, images, videos, and audio, right? Anything that you're going to be using to enrich your LLM's context window, anything that you want your LLMs to essentially know about, to have on hand as they provide a response to your user, you're going to want to consider vectorizing. Now, what might you not want to vectorize? If you are dealing with sensitive data, for example, healthcare data, or financial data, then you might want to consider not vectorizing that data and storing it alongside other unprotected data, because the process of semantic search actually ends up performing a search over your entire corpus of data. And so maybe you might want to create a separate restricted vector store for something like that. Now let's talk a bit about multimodal capabilities. And this is really the reason that we're here today, right? If we've been building with LLMs for the last 2 years, obviously text is kind of the dominant data modality, right? But increasingly over the last year and even over the last few months, as we've seen the rise of agents, right? We see that LLMs are kind of coming up with these or the foundation models are being released with these new capabilities to deal with not just images, but also real-time streaming audio, real-time streaming video, and multimodal capabilities really just unlock that next step from just text to text LLMs to LLMs that can handle that can be a business analyst over your data and look at dashboards for you, or LLMs that are looking at assembly lines and manufacturing lines and performing an initial passive QA, right? LLMs that are listening to like say you have a wildlife camera and you're listening to bird calls, and you have a microphone in a forest somewhere. Multimodal capabilities really unlock all of this for LLMs, but it's important to understand exactly how multimodal capabilities mesh into these LLMs, because it's not exactly one-to-one with how we've been just using text-to-text LLMs so far. So just zooming in into our topic for today, Gemini 1.5 Pro and also Gemini 2 will kind of, that's sort of under the umbrella of what we're talking about today. Gemini 1. The Google Gemini family of models from 1.5 onward support native audio support, or support native audio. So beyond just creating transcriptions of audio, right? Like for example, just creating a transcript of a speech, but actually understanding the content of the audio file that's passed to it. So say for what we'll see in our code example, if you pass a music file to it, it'll be able to understand the genre, and it'll be able to understand the instruments in the piece. If you passed, for example, a person talking mixed with some background noise of cars honking, and then you asked it where might this person be, instead of just in the past where we had just transcription models, closed captioning models that just gave us literally just the raw text, right? It understands that that person maybe is talking on the phone in a city or something, right? And then on top of that, we have, with the Gemini 1.5 models and beyond, an over 1 million long context window. And actually for Gemini 2, the context window, I believe, is 2 million tokens, and structured JSON output. So if you have specific items that you'd like, or specific properties that you'd like described about a certain input, so an image, for example, or an audio file, and you have predefined these properties, and we'll see what this looks like in just a second, then you can constrain the model's output to only outputting, say, for example, the name of the genre or a list of the instruments in a musical piece that you're passing to the model. Now, with obviously all of these multimodal inputs and these new capabilities that Gemini is able to perform, and on extremely low latencies, on top of that, you need a database that's able to transact, analyze, and contextualize in real time. And what this means is, for any kind of AI application, LLM application that you are, creating with a model like Gemini Flash, for example, as user queries come in, you'd like to be able to transact those queries. You'd like for those queries to be consistent. You'd like them to write to a database that you can later access that's durable. And you'd also like to be able to analyze, these queries. Over the last 10 years, we've seen the explosion of big data, and, just the importance of keeping, a well-maintained, well-annotated data set, right? There's so many data lakes that are out there that are just completely untapped for commercial potential, for even just improving the user experience. And so you'd also like to be able to analyze that data in real time. And contextualization, well, we've just covered that. Vector, semantic search, keyword search, SingleStore supports all of those features. So I'm just going to skip over a few of these marketing slides here because I know that we're all interested in the code. Just really quickly though, something that SingleStore does that, maybe you're thinking about, well, doesn't, Pinecone do semantic search? Doesn't, Postgres do, transactions in SQL, right? SingleStore is really the only platform that marries both transactions in SQL, so, your MySQLs and Postgres's of the world, and semantic search and analytics all under one platform and in millisecond latency. So, for example, if you are creating real-time dashboards, and we have a really cool demo. I created this really cool demo, or we created real-time dashboards of an MBA video or an MBA stream, and you can see only with SingleStore can you create dashboards that update in real time as an LLM contextualizes information from the video and spits out a live commentary. SingleStore is really the only platform that lets you do something like that. Just to give everyone a reminder, would love to get your participation in the Discord. I hope everyone is asking questions in the Discord. I can't be checking it right now, but I will be checking the Discord for Q&A after the code example. So we'll have time to go through questions from the Discord there. Yukti, are you seeing any questions in the Discord so far? Just curious.
I actually don't see any questions. So if anyone is having any trouble accessing the Discord server, that's just let us know. Or if you want to still follow like the traditional Q&A button, that's all right too. Like just let us know whatever's like feasible. And I'll actually put the link again in the chat. Alex, you can continue.
Yes. Okay, great. Thank you. Yeah, so would love for everyone to be participating and asking questions over the Discord because obviously, while this is a one-way webinar and live stream, we will be answering all questions afterward. So great. So the technology we'll be using today for our demo is LangChain alongside Gemini, obviously, and SingleStore. We'll use LangChain just because it's really the simplest framework to just get up and running and kind of just see the capabilities that we're interested in today. So I'm going to pause this really quickly, and I'm going to pull up the code example. Right. Let's see. One second. Let's see. Right. Make sure I'm sharing the right window. Great. Okay. So this might look a little imposing. This might look a little scary. So don't worry. We're going to be backing up, and I'm just going to show everybody how exactly they can get the code example up and running on their own machine. So what I'd like everyone to do just before we get started is to go to singlestore.com, and then you can go ahead and click this Start Free button here. And since I already have an account, that kicks me right to the home page. But if you click Start Free and you don't yet have an account, you can create an account and get started on our free share tier, which is completely free, free forever. And so as long as you stay within, as long as the constraints on the free share tier work for you, you can use it for free. But what we'll be doing is inside of SingleStore, we will be creating a new deployment. So what you're going to do is you're going to click this new deployment section here, and you'll be following the onboarding flow to create your first free shared tier deployment. I obviously already have some shared tier instances running. And so once you have those connected and you have your databases set up, which it'll kind of spin up all for you, then you can move on with me. And don't worry, this webinar is recorded. And so if you're not able to follow along just this minute, maybe you're listening in, from your car, maybe you're listening in from somewhere where don't have access to your computer, we will be sending the recording to everyone after the webinar. Great. So once you have your free shared tier instance created, you're going to want to go to this develop tab. And I believe Yukti has shared out the code to everyone in the chat. Yes. So that's the GitHub link in the Zoom chat. And once you have that code, that notebook downloaded, you can go ahead and click New under the Develop tab under Data Studio. You can click Import from File, and then import the Python notebook into your Data Studio. I already have this imported, and so I'm just going to click into that right now. What you're going to want to do after that is create or connect to your free shared tier instance. And so if you only have one free shared tier instance, you'll just see one option here. You can click that, and then you'll also connect to the database that you create during the initialization of the free shared tier instance. Great. So once we're here, we will also be needing, we'll need one other thing, and that's going to be the Google API key. I'm going to show everyone exactly how to get that. So you're going to want to go to aistudio.google.com. And then once you're inside of Google AI Studio, I'm already signed in here. You're going to want to click Get API Key and then create an API key and copy that and put that inside of your notebook. So that will be right here. All right. So once you have your API key and you've pasted it into this first cell here, you're going to want to make sure, obviously, that you install the appropriate packages. So we're just using, the Google Generative AI package, LangChain, and then SingleStore, obviously. And then you're going to want to import your API keys, configure the generative AI, the Google Gen AI SDK with your API key, and then I'm going to show everyone how you can upload an audio file with the File API. So just to give everyone an example here, I don't know if anyone's familiar with classical music, but let's see. If you go to, I'm not sure if my audio is sharing, but if you just have the notebook open, and I will just open the file for everyone here. I have no idea if the audio is sharing, but Yukti, is the audio sharing? Just curious.
Actually, not. Can you try playing?
It's not. Okay.
Yeah.
Yeah, okay. So everyone will just have to take my word for it, or you can just go to the URL if you're following along with the code example. Everyone will just have to take my word for it. I believe it is a Mozart classical music piece. And we will be using that just as an example of how Google Gemini is able to understand audio at a native level and not just at a text-based level. So once you have the URL, or the URL of the file is already in the notebook, we'll just be defining that, and then we'll be downloading the URL, obviously, downloading it as a sample, and then you'll be running genai.upload file to upload the downloaded MP3 to Google Gen AI so that it's able to, so the Gemini is able to access the file and use it as an input. So now we're going to use the Gemini model to produce an audio description of the file in question. And so we just give it a prompt, listen carefully to the following audio file. We're using, in this case, Gemini 1.5 Pro, though you can use Gemini 2. It's really a superset of Gemini 1.5. We're just not using Gemini 2 in this case because it is an experimental model, and Gemini 1.5 is the stable version that Google has released. And then we're going to use model.generate content with the prompt and the file, right? This file that we've uploaded that we get as a return from GenAI.upload file, concatenated in a list. And that lets us, that basically just lets us pass the file and the prompts together as context to the model. And then we get a fairly accurate description of the piece itself. We can also, obviously, as we mentioned before, constrain the model's output to specific schemas. So, if, for example, you're creating an app that, allowed people to upload a piece of music that they're trying, or maybe they're sitting at a symphony and they'd like to understand the music, and you'd like to be able to show predefined set of genres or a predefined set of instruments, then you might be interested in this feature, right? And that's essentially a special way of prompting that Gemini has support for, where you provide a JSON schema, right? So here we're just defining a JSON schema called musical description, and you can really write whatever sort of JSON schema you'd like in natural language. Gemini is able to understand it. It doesn't necessarily have to be one-to-one to this syntax, but here we just want to see the genre, and then we want to see the instruments, and then it needs to return us a JSON object that matches the schema musical description. And again, it's the same sort of pattern. We generate content with the contents and the file that we defined, or that we uploaded earlier. And then here in this case, we get a JSON delimited string with obviously our genre and the instruments in the piece. So with this JSON string, you can really kind of go crazy. You can do whatever you'd like with it. You can parse it as a JSON object, and have some follow-on logic that deals with the JSON object that's produced. You can validate it. You can create an enum to define specific values that a JSON field can take, and Gemini will also adhere to that. But yeah, JSON mode really allows you to productize your LLM outputs from just a proof of concept to actually something that is reliable, that is repeatable, right? Great. So we've talked a bit about contextualization. We've talked about the contextual data layer for LLM applications. And what does this actually look like in practice? Well, let's say, for example, that we have an application. Let's go back to that initial example we were talking about. An application for symphony goers that would like to know more about the music that they're listening to. And in that case, we'd like to, provide some sort of, obviously some enriched context. We'd like the LLM to be able to understand, maybe the history of the sessions that this symphony goer has gone to. And so we need to store all of this information, obviously, in a database. And so that's very simple with LangChain. SingleStore's natively integrated into LangChain. And within SingleStore notebooks, that's also very, very simple. If you just follow the cells and run the cells provided in this notebook, then you should be able to replicate the exact same results. Here, we're just importing SingleStore. We're importing the Google Embeddings model, and that's that model that actually provides the vectorization for you. And then we're going to be loading the documents into SingleStore using this initialization call. So we are creating this doc search retriever that initializes a table in SingleStore for us. It allows us to embed any text that we subsequently add. So say, for example, you know, let's say in this application that the user is also listening to, listens to some rap music, listens to some electronic music, then we might also insert into that table descriptions of that music. And then, let's say the user's chatting with their, music chatbot, and, hopefully developers in the audience can think of something, you know, a more compelling example than something like this. But let's say the user's chatting with their, their music chatbot, and they'd like to talk about, some of the music that they listen to that's related to Beethoven, right? And so here we can see, right, there's a bit of a fuzzy match, right? We're not talking about classical music. We're talking about a composer who composed classical music, right? And then we are matching that against, a database that has, descriptions of, rap music, and then descriptions of electronic music. And so this is really where semantic search can come in handy, right? Where, maybe the user doesn't even know that, the corpus of data expands all these genres, but we'd still like the LLM to be able to understand context that is relevant from the user's history, right? But there's all this kind of scattered, unrelated context, and there's no way we can do an exact keyword search, right? Because if we exact keyword search Beethoven, we have description of a classical piece, and then we have some descriptions of other genres. We're not going to find any matches, and so that's where semantic search comes in handy. And then we can see if we print the first result in our search with the similarity search, we get the audio file description that we generated earlier. So that's just really quick run through, kind of end to end, of how SingleStore works with Gemini, and how you can upload audio files to Gemini. This process you can also replicate with very little code change for images, right? For videos, Gemini supports both images and videos as input as well. But just for the sake of today's example, we're going to be focusing on audio. So I'm going to take a look. I'm going to take a look at the Discord now and see if there's any questions that have come up.
Actually, folks, for you all that have questions regarding where do you ask questions, we have a dedicated webinar Q&A server that you can see in the general section. So you can utilize that. I've already messaged there, so it will, be easier for you all to recognize. Apparently, a user has flagged that they are not able to see that channel. So if it's all right, you can utilize the any other channel. Like there's more, right? Like there's introductions built with single store. So I feel like as of now, we are okay to use something else, right? Alex, can you see that channel?
Why don't we use, just for everyone's convenience, why don't we just use the notebooks channel, right?
Awesome. Okay. So, as a mutual understanding, we can use the notebooks channel for today's questions. So I'll actually, post the links to this. So there's one general link for everyone to join the Discord channel, and then there is a specific link to go to navigate to the server that's specific to the webinar. So I'm putting all of that again in the chat for anyone that has missed. So the first link is to the channel, and the second one is like a general invite to Single Store Lab. So yeah, stay tuned for that. Alex, feel free to go ahead and head over to Discord.
Yes, I am in the Discord. Doesn't look like we have any questions so far.
Okay, so someone has actually asked a question using the Q&A button. They're saying that when trying to access the example audio file, they're messaged that they cannot access the file.
Okay. That's strange. The audio file is publicly accessible. It's just hosted on archive.org. So it may be actually what it may be is here. I'll just share my screen. You may be running into a firewall issue. So if you just if you just edit the firewall, if you go to your SingleStore Data Studio, you click into the notebook, edit firewall here, and then add archive.org. That might help. It looks like we are getting a few questions in the Zoom Q&A. So I guess while we're just sort of ironing out some kinks with Discord, I'll just field some questions from the Zoom Q&A. Don asks, how expensive is it to use the embedding model to embed a large amount of audio files? So Don, really good question. Actually, what we are doing here is we're not using the embedding model to embed the audio files directly, because that's actually something different. That's using a multimodal embedding model. What we're doing is we're using a multimodal language model and creating a text description, which then that text is embedded using a text embedding model, right? And so there's a few different approaches you can take here. A little outside of the scope of this webinar, though I'm happy to do another webinar on actually, I think we do have a webinar on multimodal embeddings. Yukti, I believe we have one.
Yes, we
I think it's like
actually have
choosing
one.
best fit.
We can rerun it, right?
Yeah, it's choosing best fit embedding. There's a webinar that I did a few months ago now called choosing best fit embeddings. Would highly recommend checking that out as a resource. In general, though, just to answer your question directly, it's not too expensive. Embedding models are really not where you'll find most of your costs, because one, you're usually not embedding too much data. Most of your costs will actually be coming from the language model and the input output tokens for the language model. Okay, so Dhruv asks, is it possible to search for similar audio based on the tunes or rhythm itself instead of a semantic text search? Yes. So again, that would be that would require probably a change using the current pipeline, right? Where we use a multimodal language model, or we start with text and an audio file that inputs into a multimodal language model, which then outputs text, which we then embed, right? What we might want to change in that pipeline is the prompt that we provide to the multimodal language model, in this case, Gemini 1.5, to maybe give a description of the the rhythm or the tunes, right? This gives us a little bit more I don't want to use the word fine tuning because it's not the right word to use here, but this gives us a little bit more control over how we'd like the audio files to be represented in vector form, compared to, like I mentioned earlier, directly embedding the audio file with multimodal embedding model, for example. So like, for example, Gemini also has, or Google also offers multimodal embedding models, which we didn't cover in this webinar, but that would be another avenue that you could use to do, to search based on rhythm or tunes. And then also, RAG is really just one toolbox that you use alongside, a bunch of other, retrieval techniques, all for the downstream purpose of providing accurate and relevant information to your LLM as it provides a response to your user, right? So, if you're actually interested in like the exact, say the beats per minute of an audio file, right? Then maybe you run that through some sort of predefined musical parser. I'm not super familiar with the space, but I'm sure there's software that exists that can, like, when you upload a file, it'll tell you, using a rules-based system, not AI, what the beats per minute is, for example, and then you can store the beats per minute as a property, you know, alongside an audio description, and then you can filter based on the property, right? And that's an exact filter. So yeah, a number of different ways you could get there, but the important thing to know is that RAG is a very important tool in our retrieval toolbox for LLMs, but it's not going to be the only tool. There's exact text search, filtering, metadata, lexical search, all these techniques that have already existed before RAG. Danvantari asks, how does JSON mode ensure consistent structured outputs? Are there validation mechanisms? Great question, actually. So the technique that I'm showing here is it does not validate the JSON that Gemini outputs at all. But there's a very simple way that you can just validate it. You can create a data model, right? So I'm sharing my screen already. Let's see. In the Gemini docs are actually very, very helpful for this. You can define a data model, right? So instead of just using, prompt that's just text, right? You can define an actual data model in Python or, whatever language that you're using. And then you can parse the Gemini response using that data model, right? And then then you get, all the rules-based checking, type checking and all that built in to your logic, right? Instead of just taking the JSON schema at face value. So that's how I would handle that. And then let's see, I believe we got a few more questions in the Discord as well, but I'm just going to cover the rest of these Zoom questions. Levantari also asks, are there API rate limits for large scale deployments? Yes, I believe there are. They're pretty high for Gemini. In my experience, I've not, just for hobby projects, I've not run into any issues, but obviously for large scale deployments, they'll charge you like any kind of model provider will. Great. So I'm going to take a look at the Discord. Doesn't look like we have. Oh, got a thank you from Technoids first. Thank you as well for joining. Okay. It doesn't look like any questions in the Discord so far, so I would highly recommend sharing any questions that you have in Discord. But obviously, we will also be fielding questions. I will also be fielding questions afterward. So, we got
Actually,
a few more
we're trying to
questions in
communicate,
the Zoom Q&A.
I'll just like to jump in and say that we are trying
Yeah.
to communicate, tell you all that we are trying to promote this community thing that we are starting. So, if you are, interested in having like an ongoing conversation with more folks that actually join the webinar, so it's like this channel is like a model for you all to stay connected and actually have a discussion. It's more like you can think of it as Reddit. Like we can start a thread and then we can chat on it, something like that. So that's the concept behind it. So if there's, and obviously, it's easier for anyone to reach out to us or like even Alex directly, right? So that's the entire concept. So I'm not sure actually, you know what, Alex, we have around over 30 people that have joined in the Discord channel, but they've not messaged. So I'm not sure if it's a glitch or something, because I've got some DMs as well that
Yeah.
I'm not able, but from my end, the settings look like they're public. So not sure what's causing that. We'll figure it out because
Yeah,
first time.
we'll figure this out after. But just to answer a few questions that I'm seeing in the Q&A here, we will be sharing, or the code will be shared out we will be recording this as well. Yeah, so the Discord is really just a channel for everyone that's joined and for future webinars. To kind of create an ongoing discussion where I can chime in, where some other experts from SingleStore can chime in, and hopefully also if you see that someone has asked a question that might be relevant to your expertise, then maybe we can also get some discussions going into Discord between community members as well. One more question in the Q&A from Rakib, who asks, is there a way to handle streaming data, audio, and video? So that's actually a very interesting question. Something that I try to deal with actually personally for this MBA analytics demo that I just mentioned earlier. To my knowledge, there's not for audio, there is native streaming for input and output, I believe. But for video, to my knowledge, you have to upload, a snippet of a video in full before you can get a response. And then your response can be streamed, but the video snippet has to be, a full video. It's not a streaming video input. So what you can do, this is sort of a hacky way around it, is you can segment the video as you receive it into say 5-second chunks or something like that, and then you can feed those 5-second chunks into Gemini, and that's one way you could kind of work around and get streaming video. But yes, you can get streaming audio as well. Great. So I guess if there's not many, Davantari asks, are there any optimizations for reducing hallucinations when processing large documents? So reducing hallucinations when processing large documents. In general, you'll find that, especially with the newer Gemini models, like a Gemini 2.0, with a 2 million token context window, you will probably be able to stuff whatever large document you'd like inside of the context window and ask your question, right? But for a large corpus of documents, for example, maybe many tens of gigabytes to hundreds of gigabytes or even terabytes to petabytes, right? That's where you'd want to use something like SingleStore to store your data, to vectorize it, and then when you do finally retrieve the data from your database, then you can kind of stuff the context window at inference time in order to reduce hallucinations, right? But that's a very high-level question, high-level answer. Happy to get into more details, but yeah. Yukti, it looks like we don't have too many more questions. We can keep the discussion going on Discord. I'm happy to answer any questions over Discord about the code. The only thing I ask is if you have a question for me, I would love to answer it in a public channel. So just so everyone else can also benefit from the discussion. But yeah, that's pretty much everything from me. You two, would you like to wrap us up?
Right. So, actually, if you prefer any other platform, let us know. We can also, make a subreddit for single store. I think we already have that, right? And we can start a thread like me or Alex, like anyone who's hosting the webinar, we can start the thread. Like this is the webinar, and if this idea is it resonates with you, let me know. You can reach out to me on LinkedIn. If you have any feedback, any ideas, if you have any projects that you're working on, you'd like us to host a webinar on that. Let us know and we can actually come up with like how do you add single store in that and how do you enhance that project? So something like that. You can reach out to me on LinkedIn. You can just connect with me anytime and let me know. You can also reach us at team@singlestore.com, and we'll also send you all a recording with all the relevant resources like Alex's code and other stuff as well. I'll make sure to figure out this Discord invite, like how it is. And I'll try to have a word with my manager regarding the Reddit thing as well. Maybe that's more because, we have some feedback that like a lot of people don't either they don't understand Discord or either they just don't use it. Like sometimes, I mean, sometimes that makes sense, but so it makes sense to have two platforms. That's what I've learned. So thanks everyone for attending. And if you have any other questions, feel free to let us know. And have a great rest of the day. Thanks for joining. Okay. Thank you, Alex. Bye,
Thanks, everyone.
everyone.